Hi everyone, today I'm going to be covering the properties of a parallelogram. Before I start this video, I'm assuming that the people watching this are already familiar with what parallel lines are. If you don't, I will give a brief overview of what they are now. So essentially, parallel lines are lines that never intersect, so they never cross each other or interact with each other, and they're always the same distance apart. So here's an example of what a parallel line pair looks like. I drew these arrows at the end of the line to indicate that they go on infinitely. So as you can see, if these go on forever and ever, they will always go in the same direction and will stay going in the same line forever and ever. They will never cross each other in any way, and they will always stay the same distance apart. So this parallel line will never go here, and this parallel line will never change directions. Okay, now that you know what a parallel line is, I would recommend going over some problems by yourself in order to familiarize yourself with some problems, as throughout most of your geometry journey, you will come across and need to use these parallel lines for most theorems in triangles and overall most things that you will come across in geometry. Alright, now we can move on to what a parallelogram is. So essentially, a parallelogram is a quadrilateral, or in other words, a four-sided figure that has two parallel side pairs. So it sounds a little bit wordy when I describe it, so here's a visual to help. Okay, here is a parallelogram. Let's use my drawing skills as they are not the best. As you can see, the parallelogram looks quite similar to a square, but you could say that it's more lopsided. Additionally, you could notice that the opposite sides are parallel. So this line, I'm using this arrow to indicate that they are parallel to each other, is parallel to this line, and this line slash side is parallel to this side. I will use two arrows to indicate that the opposite sides are parallel to each other only. So this side cannot be equal to this side, or parallel to it, and this side cannot be equal to this side. Only opposite sides are parallel to each other and are equal to each other. Great. Now that you know what a parallelogram is, I will talk about its properties. So when I talk about the properties of parallelogram, I mean the set of rules that it abides by. So for example, for a square to be classified as a square, all of its sides must be congruent slash equal to each other. So all of these sides are equal or have the same length. If this side was 5, then all of the other sides of the square must be 5 as well. So for a parallelogram, in this case, it has 4 properties. We've already covered the first properties, which is that the opposite sides are parallel and they're also equal. So as I said before, this side is parallel to this side, and this side is parallel to this side. Opposite sides are always parallel. And this side is also equal to this side, and this side is also equal to this side. In a parallelogram, the sides do not all have the equal lengths, so it does not have the same property as a square. Only opposite sides are equal. So for example, if this side was 4, and if this side was 2, and we were asked to find x, and we were asked to find y, then we would know that x is 2, and y is 4. Because we know that the property of a parallelogram states that opposite sides are parallel and opposite sides are equal. Great. The second property in a parallelogram states that the opposite angles are equal. So if I draw another parallelogram here, if you notice, if I draw a transversal that cuts between the two parallel lines, then I notice that I can use some geometry theorems, such as the alternate interior angles theorem alternate exterior angle theorem, same side interior, etc. If you aren't already familiar with those theorems, I would definitely recommend going over some problems that involve those and memorizing the theorems in order to understand why opposite angles in a parallelogram are equal. So as you can see, when I draw a transversal, it cuts the parallelogram into two triangles. And because I know that these sides are parallel, which I can use this symbol to indicate, I can see that I can apply the alternate interior angle theorem, which states that if two parallel lines are cut by a transversal, then the alternate interior angles formed are congruent. So in this case, I can see that the parallelogram forms some alternate interior angles when I cut it by transversal. So I can see that this is one interior angle, and this is another interior angle, and they're alternate. I can see that this is equal to this measure. So if this was 60 degrees, then this would also be 60 degrees. And if this was 40 degrees, then this would also be 40 degrees. And because they have the same angle measure, then this is bound to be one big angle that is equal to each other. So 40 plus 60 is 100. So this whole angle is 100. And 60 plus 40 is also 100. So this whole angle is also 100. As you can see, they have the same angle measure. So if I were to give you a problem that states, find the measure of angle X, and you were given that this is 60 degrees, then you would know that X is also equal to 60 degrees, because the property of a parallelogram states that opposite angles are always equal. Great. The third property of a parallelogram is that adjacent angles always add up to 180 degrees. When I say adjacent, I mean angles that are next to each other. So again, if we use some geometry theorems like the same side interior angles theorem, which states that if two parallel lines are cut by a transversal, then the same side interior angles formed are supplementary. When I say supplementary, I mean that it adds up to 180 degrees. So in geometry, you will often hear people say supplementary, which is what they mean by that. So in this case, I can see that these two angles are next to each other. And same with here. And it goes around in a kind of cycle. So this angle and this angle adds up to 180, this angle and this angle adds up to 180, this angle and this angle adds up to 180, and this angle and this angle adds up to 180. But the opposite angles do not add up to 180. It is only the angles that are adjacent or consecutive. So for example, if this was 100 degrees, then I would know that 100 plus, let's call this angle X, is equal to 180 degrees, as they are adjacent angles. 100 minus 100, 180 minus 100 is going to be X is equal to 80 degrees. So I would know that X is equal to 80 degrees, as they are same side interior angles, and because the property of parallelogram states that they are supplementary. Additionally, I can notice that the opposite angles are equal to each other, so I know that this angle is also going to be 100 degrees, and this angle will be 80 degrees. Because I know that, I can see that this angle and this angle adds up to 180, because 80 plus 100 is 180, 100 plus 80 is also 180, 80 plus 100 is also 180, etc. and etc. Which is how you see that it all adds up to each other. Great, we're almost done with stating what all of the properties of a parallelogram are. The last property of a parallelogram is that the diagonals always bisect each other. So if I draw another example of a parallelogram, if I draw a transversal that cuts through them, I can also draw another transversal here. And I can see that they both bisect each other, which means that they cross each other or intersect. So the property of a parallelogram states that this side must be equal to this side, and this side must be equal to this side. So if this side was 4, and this side was 5, and it was asking us to find x and y, then I would know that y is equal to 4, and x is equal to 5. Note that they are not the same length because this side is not equal to this side. They're only equal to the lines that are next to each other. And that is the properties of a parallelogram. I will now give you some problems to solve on your own, and I will do one more problem additionally before I give you those. Okay, here is a problem of a parallelogram that we will solve together. So I can see that it is asking us to find from x, y, and this length, which we will call z, and this line, which we will call r. Okay, because I know the properties of a parallelogram, I will solve z first, but you can really solve any angle or side that you would like to solve. So the first property of a parallelogram states that opposite sides are equal to each other. So I know that this side is 2, so z must also equal 2. Z equals 2. Great, we have the first length done, which I'll put a little checky mark here to indicate that we've solved it. And I can also see that 6 is equal to r because opposite sides are equal, so r is equal to 6. Okay, now we've solved 2 lengths. We only have 2 more variables left. Okay, I can see that it is asking us to solve x and it is asking us to solve y. I will solve x first. So because I know that opposite angles in a parallelogram are equal to each other, and I know that these 2 lines are parallel, I can see that it forms alternate interior angles, so x must equal 40 since it's alternate interior. X is equal to 40 degrees. Additionally, this must also equal 60 degrees because they're also alternating interior. Okay, the last length that we will try and solve for is y. The fourth property of a parallelogram states that diagonals bisect each other. So I know that 4 is equal to y because this length must be equal to this length. Y is equal to 4. It did not ask us to solve some same-side interior angles, but if it were to, because I know that this is 40 degrees, this adds up to 100. Thus I know because these are same-side interior, this must add up to 80 degrees following the third property of a parallelogram. And that is how you solve a problem when it is asking you to solve either the angles or lengths of a parallelogram. I hope that this video helped, and now here are some problems that you can solve on your own.